good, everybody? Let's just shake it out real quick. I know we had a lot of presentations and stuff like that, so get some energy flowing up in here. Alright, so as you guys know, my name is Kunal Bagga. I've decided to do neuroscience of motor imagery. So kind of just giving a little definition real quick. Destiny was actually one of the pioneers in this for motor imagery. Quick little definition, obviously in 1996, again, one of the first pioneers. This is referred to as a dynamic state during which representation of a given motor act are internally rehearsed in working memory without any overt motor output. Simply said, it's the internal rehearsal of a motor act without actually performing it. So kind of just getting into evolution, kind of started with Destiny in 1990s and kind of still going, there's still ongoing research about it. All these are kind of just different terms that have been different ways to describe it, but they all have kind of slight differences. So how should motor imagery be done? So Toth and colleagues in 2020 actually had a 24-year follow-up review that had to do with all of the research that had been doing previously on motor imagery and mental practice, and they kind of put it all together and were able to get the good things out of it. The things that they got out of it was that the 1 to 6 week studies were the best studies to actually look into. 20-30 minutes was the optimal time for doing visualization. Mixing kinesthetic plus visual strategies were best. So obviously you have a script that you go through when you're in imagery. You want to be able to perceive and feel. Kinesthetic is referring to like bodily sensations and stuff like that. So in basketball, talking about the hips and stuff like that, hips, all your different joint angles and stuff like that. Visual is talking about more, obviously, your visual cortex. Some limitations on this were cognitive fatigue. 0 minutes and 60 minutes were the outliers. You didn't want your practice to be too short. You didn't want it to be too long because cognitive fatigue sets in. Motor imagery ability was also another limitation just because we're all individuals. We're all different. Not everyone can imagine the same as each other. So simply put, it's not for everyone. That's all cool and all, but why does motor imagery actually work? All kind of started off with this thought by William James in the 1890s. And again, this was just a thought, didn't have no evidence behind it. And what he pretty much says, every mental representation of movement awakens to some degree the actual movement, which is its object. Again, simply put, every time we actually move, we plan through mental rehearsal. So that was, again, just a thought, and this pretty much got everything together and was able to spark research into the subject. And then about 100 years later, in 1990s, again, Destiny pops up. Being an initial pioneer, Generrod is another person that kind of made it more famous. So they're kind of a collaboration between the two. And what they said was one can compile the goal, plan, motor program, and outcome of an action during imagined action similar to overaction. So they kind of put the thought of William James, put some evidence behind it, put a theory behind it, and then it pretty much saying that the parts of the brain are similar with imagined versus actual actions, right? Contradiction, right? So that was kind of older research. More recent findings have found that through like detailed fMRI studies, and as you can see here, laser pointer, this is the motor execution one. We're actually doing the movement versus motor imagery, more talking about thinking, planning of the actual movement. And as you guys can see, yes, they're similar, but they are significantly different, distinct regions, right? So just previously, Destiny and Generrod had said that they were very similar. This contradiction came in and yeah, they're similar, but they're not quite the same. And as you can see, another thing to notice is the volume activated is actually less than half of what is activated in actual motor execution. And why is that? We're going to get into it there. So again, why are motor imagery and actual movements different? We're able to explain all of this through one example, which is of shooting a basketball. Example of shooting a basketball, we always plan backwards. We have an intended plan, we have an intended effect. We plan on shooting this basket. Even us simply thinking about shooting that basket, there's a split second that happens in between that there's so many different things that are going on in that split second. The muscles that we're going to be using, what is going to be contracted and not extended and stuff like that, we don't know. It's pretty much the hidden machinery of nerves, where we're more talked about, William James actually talks about this as well, we're more intricately known about the outward results of our volition rather than the hidden machinery of nerves. Pretty much saying that. The actual effect is the outcome, so whether or not we make or miss the basket. So again, the motor commands are created and sent to the muscles, and then we have two different options. And it all has to do with our relationship between our plan and our outcome. Is our plan a good plan or is it a bad plan? Did it allow us to have the outcome of success, or did we miss the shot? Did error come into play? In motor learning, in motor control, error is probably one of the most vital things to motor learning, right? Without error, you cannot make any corrections, you cannot detect any corrections. And the thing is that in motor execution, actual movement, actual execution, there's feedback. Feedback is allowing you to detect and correct these errors. The problem here is that motor imagery does not have any actual effects. There's no actual outcome. We don't know if our plan was a good plan, we don't know if it was a bad plan. We don't know if our plan was perfectly planned or if it wasn't perfectly planned. Obviously, because we don't know if we made or missed the shot. So again, you're missing that rich feedback that's happening during execution. So thinking about, going back to this slide of the neuroimaging, why is this volume so much less? It makes 100% sense, obviously, because we have less sensory information, there's less activation of the brain, so it having less than half of the volume is not a surprise to me, right? So we kind of got all that. Again, feedback is the key here. We do not have the resources available to actually detect and correct these errors in motor imagery, right? So kind of getting on to a more different viewpoint again. There's a lot of different viewpoints, and this one is referring to the perceptual cognitive scaffold, pretty much saying that actual execution is more rich than what you can consciously recreate. Not only referring to the fact that it has rich feedback, but also to the point of that based off of previous experiences and our subconscious, there's many things that are going on right now as we speak, subconsciously and consciously, that we are simply not aware of. There's our stuff that are coming into our peripheral vision, our visual, the tactile sensations, our auditory, all these different things are happening almost subconsciously. So in motor imagery, it's actually very hard to recreate all of this in exact detail, right? You pretty much, there's a conscious limit to what you can create. And we kind of get into this, into an example of a pro versus novice scaffold in a basketball player. So being a more advanced player, you can think of many different things. We can see through our peripherals when I'm visualizing. I can see help defenders. I'll be able to feel out the help defense. I can see the defender's feet. I can see the hip movements of the defender to be able to use his momentum against them, to actually be able to use leverage to get into my driving angle. Novice doesn't even know what I just said right there. Pretty much, right? The novice is not aware of all of these different things, so they do not have as detailed of a scaffold, right? So these are kind of the two main points on about motor imagery and why it's different than actual execution. So summary and conclusion. In order to have effective motor imagery, you want to have 20 to 30 minute sessions. 1 to 6 week studies were the best. 4 to 6 weeks is the best time period to go about. Again, kinesthetic and visual mixed strategies is the best way to go about it. Kind of again talking about just a review, William James started off with a thought. We backed that thought up with evidence. There was contradiction to that evidence, and now we're here. There's still a debate going on. There's still ongoing research on the topic, so it's still a thing that's being more researched about, right? So kind of after all this research and stuff like that, I had an opinion, obviously, of myself. Motor imagery was kind of more thinking about the thinking, planning, and the neurophysiological processes that are happening. But what I found was that it's missing a viewpoint. Coming from being a double major with both kinesiology and psychology, I wanted to be able to integrate both into this project. But what I found early on was that there's much more research on motor imagery than there is on mental practice. Mental practice, I'm more referring to, again, from a sports psych view, is talking about more the mental states, the emotional regulation of the actual psychological aspects, which none of these even talked about. So I think that's a very big missing piece. I think future research should somehow be able to combine the both to be able to actually see and see how well imagery can work, right? So kind of just, again, I do think motor imagery is good. Again, it only reduces error to a certain extent because we do not have the actual outcome. But again, it is still inferior to actual execution. Yep. Any questions? What to do, baby?
So why do you think there was such a big gap, that 100-year gap between the initial and the research?
Why do I think so? I'm not sure. I'm not sure about that. Again, there's still a debate going on, still ongoing research. There's so many other things. When that first started, they wasn't giving detailed fMRI. That's also what I found out when I showed that neuroimaging pic. That was a detailed actual fMRI. When Desity and General actually first talked about it, they were more talking about the neurophysiological aspects, but the neuroimaging part wasn't as used back then, at least.
Gotcha.
Yeah, of course. Thank you. Yep. Yep.
No, I don't know exactly what you want to do in your future. I don't know if you know that, but can you tell me, can you visualize or imagine how any of what you have done in research here might translate to what you want to do?
Yeah, so right now I'm still trying to go play pro basketball. I've been using visualization probably for like 3 years now, so that's probably why I actually got interested into the topic, and like a lot of like the optimal time and stuff like that, I kind of knew of it before, but as far as like the whole like motor imagery versus mental practice and stuff like that, being able to actually be able to separate the two, I was not aware of that. But yeah, I'm very interested in like neuroscience, motor learning and stuff like that. So yeah, if I were to do like graduate school or something like that, I would definitely do something like this. Yep. Yep.
So then you kind of talked about how can we maybe combine the research now, right? Kind of you focused on the motor imagery aspect, but how can we make sure that, you know, using visualization, using imagery, how can we make it most effective if there is that kind of difference between, you know, imagining the movement and the actual performance of the movement?
Bingo, I'm glad you asked me that question. I actually got some more stuff on it. Right here, in 2001, Holmes and Collins actually developed something called the PETLET model, and that was pretty much just like a 7 specific protocol of how to make imagery as much like actual motor execution as possible. So that's pretty much what he's doing. And kind of just reviewing this real quick. Physical is talking about like, is your heart rate increased? Yes, when you're actually executing something, your heart rate is increased. You're much at a different state than you're actually like just chilling, like relaxed, like visualizing something. You feel me? It's much different. As far as environment, you want to make it as game-like as possible, right? You don't want to have it into a practice environment because it's just not as translatable. Task is referring to it being more like externally cued versus internally cued. Is there object manipulation and stuff like that? Timing is more talking about making sure it's in real time, making sure it's not in slow motion, obviously. Learning, there's different stages of learning. Pro is different learning than versus a novice, so taking that into account. And then again, this kind of mental states and stuff, emotion, it slightly talks about it, but as far as like deeply getting into the subject, they do not get into it, or at least I haven't found anything on it, right? Again, emotion talking about more like the mental states, emotional regulation, and of course like you want to be able to see the point of view in first person, so you're actually like can visualize yourself doing it. But yeah, thanks for that question.